NASA has unveiled fresh images of an interstellar object which astronomers classify as a comet, potentially older than our solar system itself. The initial indicators were a subtle asymmetric glow, discernible only at the profound depths of the James Webb Space Telescope's capabilities, alongside an unusual spectral filament that did not conform to any known categories of outgassing mineral reflection or thermal emission. At first, astronomers believed they were tracking yet another peculiar artifact from the interstellar visitor 3I Atlas, a fascinating entity that ranks as only the third known object to wander into the solar system from the boundless stretches of interstellar space. However, as the light persisted, intensifying and proliferating at the wavelengths for which Webb was calibrated, it exhibited a steadfast consistency that set it apart from debris and dust, displaying too much structure to merely be noise. Even prior to the compilation of the most intricate datasets, an increasing number of researchers recognized that something extraordinary was unfolding. Webb had captured signs that were entirely unexpected for such a small, icy interstellar body. Organic complexity beyond non-biological origins, patterns within molecular absorption bands suggesting metabolic cycles, and a spectral fingerprint that bore no resemblance to anything found in our solar system, but aligned with the general anticipations of biological chemistry. News spread rapidly, nearly echoing the movements of 3I Atlas itself as it glided into its elongated, shallow orbit around the Sun. For years, scientists had been anticipating the first clear, undeniable indication of extraterrestrial life. Signals they had long assumed would emanate from a distant exoplanet, boasting an atmosphere rich in sophisticated biological markers. Yet few expected it to arise from a minuscule interstellar object, silently traversing the outskirts of the solar system while seemingly harboring ancient, unseen secrets. What is most astonishing is not merely the unexpected nature of this revelation, but the distinctive characteristics of 3I Atlas. Unlike the familiar comets of our solar system, it possesses the chemical signatures of an alien star system, derived from formation processes entirely separate from our own cosmic environment. Its presence is a rare occurrence on its own, but the accumulating evidence suggesting it may host a micro-ecosystem has elevated 3I Atlas from merely an alien object to a legitimate interstellar messenger. The signals detected by the Webb Space Telescope, although faint, exhibited too much structure to be dismissed as mere coincidence. In the mid-infrared spectrum, the spectral absorption patterns uncovered complex carbon chains, with lengths and structures that were challenging to associate with conventional non-biological chemistry. Hidden within these patterns were traces of amino acids and stable polymer frameworks that absorbed and emitted energy in a suspiciously periodic fashion, closely resembling the energy transfer mechanisms observed in known living systems. Notably, these patterns do not appear in isolation. They are nested structures adhering to the same regulatory principles employed by bacteria in forming colonies within porous microenvironments. The variables that intrigue researchers extend beyond mere complexity. It's their variability that captivates. Webb has noted fluctuations in the concentrations of these molecules over time, a behavior more akin to a biological response to changes in the local environment than a passive chemical phenomenon. As 3I Atlas continues its journey deeper into the inner solar system, those kinematic signals are becoming central to a bold hypothesis taking shape: that the body may not only contain organic matter, but could also be host to microscopic life forms that are too small to be seen by the naked eye, yet undeniably alive. Resilient microbes adapted to the harshness of interstellar travel, or, as some cautious scientists propose, the remnants of an ancient biome from a long-lost civilization or planetary system. Whatever the reality may be, 3I Atlas compels humanity to reassess its assumptions about the origins and distribution of life in the universe. It's conceivable that the initial signals we receive are merely the thin ice masking deeper secrets poised to be revealed from the shadows between the stars. The ramifications of this discovery extend far beyond the conventional confines of astrobiology. Should life be able to thrive on a diminutive body without the safeguard of an atmosphere, a stable thermal environment, or the magnetic protection of a planet, it could indicate that the entire universe is teeming with tiny microbial vessels silently traversing distances once deemed insurmountable. In such a scenario, life would not be restricted to its birthplace. It could drift, disperse, and sow new life into the cold, dark voids between stars. What troubles many scientists is not merely the potential for life to migrate, but the more profound question: are we witnessing the initial evidence of a galactic biological network in which primitive life forms are transported across the cosmos, either unintentionally or purposefully? As 3I Atlas continues to delve deeper into the solar system, the rate of data collection has surged dramatically. Webb has refined its entire observation schedule, making the object a priority in every conceivable timeframe, even adjusting timelines for observing distant galaxies to capture individual photons from this nearby interstellar body. The project has rapidly evolved from a small team analyzing a handful of spectral anomalies into a global collaborative effort, engaging experts in microbiology, planetary chemistry, astrophysics, evolutionary science, and even those specializing in theories about the origin of life. The atmosphere within the scientific community has been charged with tension. Every new data point is being examined as if it holds the key to a truth poised to revolutionize human understanding. Some experts have even cautiously suggested that if 3I Atlas indeed harbors life, it is unlikely to be a mere coincidence. Could it be the remnant of an ancient biological transport system employed by an enigmatic civilization? Or are we observing a kind of galactic mechanism for the transmission of life? A cosmic protocol designed to sustain biodiversity on a grand scale? The closer 3I Atlas draws, the more curiosity intertwines with a sense of dread as it brings secrets that humanity may never be fully prepared to confront. The most significant challenge now lies in differentiating signs of life from bizarre but non-living chemical reactions, particularly regarding an object of extrasolar origin, where the chemical conditions may well exceed familiar norms. Much of the scientific community remains cautious, yet existing models are gradually dispelling the last remnants of doubt. The ratios of organic compounds found on 3I Atlas are too skewed to stem from purely abiotic processes. Periodic concentration fluctuations indicate the presence of a dynamic feedback mechanism. Certain spectral lines even suggest the existence of radiation-absorbing compounds akin to biological pigments, a plausible adaptive strategy for life facing the intense cosmic radiation, perpetual cold, and sudden alterations of the interstellar medium. As the data become clearer, skepticism is slowly shifting to a cautious but palpable confidence. A pivotal moment occurred when Webb recorded an unusual, almost explosive surge of infrared fluorescence precisely when 3I Atlas was impacted by increased solar radiation. The intensity of the emission exhibited a rise and fall in a manner closely mirroring the responses of familiar biological systems to light. The organisms inferred from this behavior seemed capable of utilizing, or at the very least regulating, the energy they receive, suggesting some form of simple yet intentional metabolic activation. This singular observation was sufficient to prompt science to rethink many of its foundational assumptions regarding the limits and scope of life. If confirmed, the life forms on 3I Atlas would no longer be perceived as passive entities trapped in ancient ice, frozen in time, but as active survival mechanisms capable of harnessing every rare ray of energy, adapting to absolute isolation, and remaining operational even while drifting through the cold void of interstellar space for millions of years. Within this different context, 3I Atlas symbolizes more than just a carrier of life. It serves as living testament to the notion that the universe might be a colossal ecosystem, wherein life doesn't wait for the perfect environment to thrive, but rather learns how to establish its own rules for existence. Each fresh observation incites a fundamental question: where did this life originate? The trajectory of the object traces back to a galaxy region reputed for star formation, dense nebulae, and turbulent stellar nurseries. Somewhere amidst that vast expanse, a planetary system likely birthed these microbes. The chemical signatures detected by Webb point toward a biochemistry based on carbon, yet not reliant on carbon alone. Trace metals are intricately interwoven with organic compounds in a way that terrestrial organisms cannot replicate independently. Some scientists speculate that life on 3I Atlas may indeed predate our solar system, having descended from a lineage that diverged from Earth-based life's chemical ancestors billions of years ago. Others propose that this is a relatively youthful life form evolving under conditions so different from Earth's that its trajectory represents a parallel experiment conducted by nature on a galactic scale. The implications for panspermia have never been more profound. For centuries, the notion that life could traverse between stars has been deemed a bold conjecture, often overshadowed by biogenesis models centered on stable planets. Nevertheless, should 3I Atlas be validated as a living entity, it would represent the first direct demonstration that life can not only endure beyond Earth, but also survive the treacherous interstellar voyage. This would imply that life in the universe is no longer a static phenomenon rooted solely in its place of origin, but a mobile entity capable of spreading through natural mechanisms, akin to icy bodies expelled from their parent star systems by gravitational forces, journeying through space for millions or even billions of years before encountering a new planetary system. This viewpoint significantly redefines humanity's position within the cosmic landscape. If life can traverse so freely, the distinctions between biospheres become increasingly nebulous. Earth may not stand as an isolated oasis, but rather as merely one link in an ancient network of biological exchange that spans across the galaxy. This leads to bold hypotheses suggesting that Earth's genetic heritage may not have originated solely from here. Instead, it may represent a fusion of native life currents and extraterrestrial seeds that converged in the distant past. Conversely, should the microbes on 3I Atlas be entirely unrelated to life on Earth, the discovery still marks a transformative shift in scientific paradigms. It suggests that life isn't an anomaly confined to the isolation of the solar system, but may have arisen multiple times across the galaxy, employing adaptive strategies and molecular structures wholly independent of known biological norms. Regardless of the scenario, both outcomes expand the realm of astrobiological possibilities beyond anything previously envisioned. This discovery also highlights the remarkable resilience of life. Interstellar space presents an almost insurmountable environment for any typical organism. Extreme cold, intense radiation, and a lack of energy or stable surroundings. For organisms to survive such a journey, particularly while maintaining minimal metabolic function, they must possess protective mechanisms far exceeding anything ever documented on Earth. Webb's data indicate the presence of concentrated radiation-absorbing compounds, akin to protective pigments or photoprotectants. Certain spectral features hint at polymers capable of repairing molecular damage, functioning as a form of biological armor that may have evolved to withstand harsh conditions over millennia. When compared to the extremophiles on Earth, the level of endurance suggested by 3I Atlas far exceeds anything previously recorded in biological models. This implies strong evolutionary pressures urging life not only to adapt for endurance, but also to function reliably within the stark isolation of deep space. Attention is now fixed on what will transpire as 3I Atlas approaches the Sun. Researchers remain reluctant to comment on potential long-term implications or societal reactions that may arise. However, they recognize that the object's changing environment offers an unprecedented opportunity. Rising temperatures will modify the structure and activities of organic molecules imprisoned in ice. Increasing radiation could trigger new chemical cycles, unveiling unique spectral signatures that Webb could analyze with unmatched precision. The sublimation of volatiles may liberate trapped microorganisms into the surroundings, creating a biologically rich temporary atmosphere that could aid observers in searching for more nuanced samples. For the time being, the scientific community's focus remains concentrated on a singular point: Webb's groundbreaking discovery, which increasingly presents compelling evidence for extraterrestrial life, and its extensive implications for biology, astrophysics, and humanity's comprehension of the universe itself. Initial assessments of this discovery acknowledge the nearly overwhelming intricacies of its ramifications. Should life indeed exist on 3I Atlas, it would necessitate the re-evaluation of numerous long-held beliefs regarding the origins of life on Earth. Although scientists remain cautious and are not prepared to assert definitively that life on Earth arose from outside our solar system, the presence of life forms on an interstellar object robustly supports the thesis that organic building blocks, or even fully developed organisms, may have played a significant role in seeding early Earth. The notion of life traversing across the cosmos, a concept long considered intriguing yet highly speculative, now appears more plausible than ever, especially with the icy messenger that is 3I Atlas arriving within our solar system. Yet rather than getting caught up in extravagant conjecture, the scientific community remains focused on the discovery itself. One of the most critical aspects of this finding is its illumination of the dynamic interconnectivity of the galaxy. Should 3I Atlas harbor life, it implies that the Milky Way is not merely a random assortment of isolated star systems, but rather a vast network of exchange where matter, energy, and possibly life itself are in constant motion. As young star systems form, as planets shift, or as orbits are perturbed by gravitational resonances, many smaller bodies are expelled from their familiar environments and drift into interstellar space. Some of these may bear organic matter or early life from their worlds of origin, embarking on a journey across the galaxy that could last millions or even billions of years. Over these infinite eons, interstellar travelers become invisible ambassadors from distant solar systems, carrying with them chemical and biological imprints of their origins. Webb's findings suggest that the Milky Way may be teeming with such ambassadors, each one an archive of its biological environment, patiently waiting for a civilization advanced enough to recognize and interpret them. Moreover, the complexity identified by Webb on 3I Atlas leads to an even bolder conclusion: that life does not necessarily require a stable planet for its formation. While planets and moons have traditionally been deemed the most suitable environments for life, given their access to abundant energy sources and stable conditions, it is now conceivable that smaller bodies could also sustain life for extraordinarily long periods, even far from their parent star. The hollow cavities within interstellar objects might function as ideal microbial habitats, maintaining minimal temperatures, shielding against radiation, and generating the chemical gradients vital for basic biological reactions. Should organisms housed within these cavities be capable of prolonged dormancy, reviving only when external conditions shift, such as upon nearing a star, then even the frigid isolation of space may not extinguish the flame of life. In this context, 3I Atlas emerges not merely as a visitor traversing the solar system, but also as a fragment of an incomplete cosmic puzzle, possibly humanity's first clue to answering one of its oldest questions. Are we truly alone in the universe? Considerable attention has been directed towards the nature of the chemical systems discovered by Webb. The organisms, if indeed they are such, appear to utilize a biochemical toolkit that melds familiar elements with novel ones. The incorporation of heavy metals suggests biochemical pathways reliant on catalytic surfaces not observed in terrestrial life. Some researchers have likened this to metallic microstructures or nanoscale frameworks. Rather than depending solely on fragile organic enzymes, these organisms may have evolved hybrid biochemical mechanisms that integrate mineral-like components, thereby enhancing their resilience to harsh environmental conditions and allowing them to endure the molecular chaos wrought by cosmic radiation. As data accumulate, the portrait of 3I Atlas becomes increasingly intricate. It is not a monolithic entity. Its structure encompasses dense icy regions, porous networks, rocky inclusions, and organic-rich pockets where spectral signals indicate heightened biological activity. These pockets display behavior akin to miniature ecosystems, each reflecting a slightly different chemical balance. Webb's instruments have tracked fluctuations within these pockets, unearthing cycles that rise and fall in response to rotation, sunlight exposure, and the internal heat distribution of the object. Such cycles reinforce that this is not merely a static chemical relic of ancient processes, but rather a living, constantly evolving system. One of the most captivating aspects of this discovery is how it reshapes our understanding of the chemistry within the interstellar medium. For years, astronomers have scrutinized complex organic molecules drifting between stars, marveling at their diversity. Yet making the leap from molecular complexity to actual biology seemed daunting. Now, with 3I Atlas acting as a bridge linking interstellar chemistry to living systems, the divide appears considerably narrower. The galaxy's molecular clouds, already known to harbor water, carbon monoxide, methane, and polycyclic aromatic hydrocarbons, could serve as reservoirs supplying the ingredients necessary for life on countless worlds and objects. This discovery intimates that these regions might even contain life-bearing debris ejected from planetary systems, allowing organisms to traverse star-forming areas, like seeds caught in the cosmic breeze. The hypothesis that life may constitute a galactic phenomenon rather than a rarity confined to planets is gaining traction. Webb's revelations have fostered a re-evaluation of the infrequency of biological life. If life can exist on an object as diminutive as 3I Atlas, amidst the harsh realities of interstellar space, then life's emergence might be a natural outcome of galactic chemistry rather than an extraordinary fluke. Life could be as integral to the Milky Way as star formation itself, a recurring byproduct of processes occurring throughout the galaxy. Some researchers surmise that the life present on 3I Atlas could represent only a minuscule fraction of the invisible biological presence threading through the galaxy. Yet amid these significant discoveries, scientists persist in their quest for direct evidence. They focus on spectral data, recurrent molecular signatures, and rhythmic concentration shifts. They meticulously chart the regions where biomarkers peak, tracking them both across the surface and within the object itself. Each dataset returned by Webb enhances the excitement, all while avoiding speculation regarding future developments. The emphasis remains on documenting this unprecedented event, the revelation that this interstellar body is not lifeless, but rather a vessel transporting microorganisms across the interstellar divide. The approach of 3I Atlas does not induce urgency. Instead, it cultivates a sense of anticipation. The closer Webb gets to the Sun, the more apparent the biosignatures it detects become. Increased illumination prompts organic compounds to react, releasing a haze of sublimated volatiles that carry organic materials into the surrounding space. This haze facilitates Webb's collection of more detailed spectral data, revealing compounds previously obscured in ice. Initially, light transformed into a complex halo of activity. The molecular patterns within the haze indicated organized clustering. Some compounds formed protective structures around biological cores, while others radiated outward like an organic scaffold. These indications suggested the presence of internal cooperative systems akin to the multicellular organizational forms, reflecting survival strategies within the interstellar medium, where organisms could only thrive by sharing both protection and energy. Each new observation continues to underscore the wonder of this discovery. Life beyond our solar system is astounding, yet its presence on a tiny wandering object imbues the universe with a greater sense of intimacy and mystery. Life is no longer confined to a planet. It is a cosmic traveler capable of crossing between star systems. In this framework, Webb, originally designed to explore distant galaxies and their faint infrared emissions, unexpectedly evolved into a tool for biosurveillance. Its heightened sensitivity and resolution revealed subtle distinctions within intricate carbon compounds, creating a detailed mapping of molecular relationships existing under otherwise impossible conditions. With Webb, the study of life has transcended planetary science, venturing into the sphere of biology on a galactic scale. As observations progressed, the scientific community gradually reached consensus that biology is not exclusively the domain of Earth. The implications of 3I Atlas extend across every field related to life, energy, evolution, and cosmic processes. Though scientists have refrained from discussing the enduring repercussions, all comprehend that this represents one of the most pivotal moments in the annals of science. Webb has illuminated that the universe is not silent. Life is not an improbable reality, but rather a dynamic presence drifting among the stars. This revelation is unfolding right now, as a fragment of a distant world approaches our solar system, meticulously tracked by Webb with unprecedented sensitivity. The growing brightness encircling 3I Atlas serves as a living chronicle of the transformations taking place within, where chemical signatures shift and unveil fresh layers of secrets. Each observation unlocks another glimpse into the enigmatic interstellar realm. As the object traverses more temperate regions, its internal biological architectures, if they can be referred to as such, begin to showcase even more intricate patterns. Initial organic alterations swiftly develop into a cascade of molecular reactions, akin to biochemical ripples adapting to the new environment. Though transpiring quietly in the cold expanse, these changes hold immense scientific significance. To decode them, researchers have broadened their analyses to include previously overlooked small molecules. Certain chemicals emerged as common intermediates in energy metabolism and biological structural development. Their concentrations fluctuated over time, forming activity curves reminiscent of the metabolic rhythms found on Earth, but not aligning with any familiar biochemical framework. These reactions create a branching web, with each node representing a potential function that the organism can activate in relation to prevailing conditions. Notably, many of these reactions appear to rely not on water, but on supercooled volatiles, fostering a stable microenvironment even amidst the extreme chill of 3I Atlas. This alludes to a completely novel form of biology operating under unfamiliar yet consistent rules, revealing the possibility of life existing and thriving under conditions unknown to Earth. Another element that captured researchers' attention was the discovery of small crystalline structures concealed within the organic pockets. Webb's infrared data indicated that these crystals did not originate from the surrounding bedrock, but rather formed through recurrent cycles of sedimentation and dissolution. They contain thin layers of organic compounds, arranged in sequential layers. Some layers exhibit gradual accumulation, while others undergo rapid formation due to fluctuations in temperature or radiation. If you found this video engaging, please give it a thumbs up and subscribe to our channel. We'd also love to hear your thoughts in the comments below regarding 3I Atlas bringing life to humanity and how we should respond next. Thank you for watching, and we look forward to connecting with you again soon.